Hello, everyone. Let's make sure okay. Yep. So this week we're going to just do kind of a review again over if we go to our camera component, we are doing just a review of screen to world space, and then briefly over scene management, and then we will be making um a camera shake effect, because that is a prominent thing in many games, and it can be a little bit complicated with how to implement it. And then the other thing is that we will just do a basic slash attack and then have a special attack that with some logic in there that might be kind of complicated, um, specifically like in-air attacks and stuff like that, where we don't really have that fully expansive collision system, so it can be hard to have some specific requirements. But first, let's review screen to world space. So with screen to world space, the main thing we do is we're given a point on screen space. And what we do is we establish a down point, um, which is something built into JavaScript. And then we also set up a down matrix. And what we do is just like a matrix, we'll do kind of a brief overview. There is B, C, D, E, F, H, I. All right. So a dot matrix is either a 3x3 or 4x4 matrix. In this case, we could just say it's a 3x3 for simplicity. But what we do is when we translate self based off this matrix, we just adjust these values based off of the inner width and inner height point. And then we also do that again for the camera main transform position. The way we find that, or the way we kind of came to that conclusion, was because we will be reversing this process. So we just followed the same steps over here into our camera. And then what we do now is that we just get that matrix inverse, and then given that screen matrix, we input a point, and then it says, hey, now it converts it into where it is in the world, and then we return that as a new vector 2. So it is literally just the reversal of this, pretty much. For scene management, we change it so that now we have load scene and get active scene. So now when we want to switch scenes, we say, hey, we load scene. And then in static scene, or in order to get the current scene, we always do the get active scene. And then another thing is game objects. One thing we are going to do now is we're going to use broadcast message. I had an error in mind, so I will be debugging that. But that's how you do broadcast message. And then what you do for start is this dot broadcast message with the string start. And then yep, and then in scene, now we also added a global instantiate. So now you don't have to worry about getting the current scene and any of that stuff. We just say, hey, let's globally instantiate something, and it handles all of that for you. What else? Is there anything? I think that's it. One thing to note is that there may or may not be more stuff to Scene Manager coming. One issue that may happen is that when you load scene, so if you load in between a scene, so say for example you have 5 game objects, and those game objects communicate to each other. Well, what can happen is if you switch scenes while there's game objects remaining left to be updated, that can cause an error of undefined because it won't be able to find that game object. We will worry about that later. There's still some stuff with that, but otherwise now you can switch scenes and that stuff. So we might briefly demonstrate that, but otherwise that's pretty much it for the weekly review. The main thing I wanted to do was the camera shake. So if you go, I went to, since camera is something kind of is something we've included, and how we're going to implement it, we will just have it attached to the component. So if we go to our camera game object, I will always just have the camera game object have the ability for the camera to shake. And what we will do is whenever we want it to shake, we will call start shake, which will instantiate variables in order for that to happen. But so the first thing we want to do is we need to make sure base position has a value. So we will just say, hey, if there's no base position, we just return nothing. And then so then if there is a base position, we need to shake. So is shaking. Base position is the thing that you will be following. So we will have to update some stuff, but and there's a couple ways to do camera shake. I have found that the most useful way is to just create an offset variable that's randomly generated. So what we'll do is we'll say, hey, let offset x, and let's set that equal to 0, and let offset y equal 0. And then inside of the is shaking, what we want to do is we want to see how much time has elapsed. Because obviously, as time continues, the shaking should decrease to 0. So what we'll do is constant, let's say, progress, and then we just do a simple this dot time divided by this dot x duration. And now what we want is we want to get the magnitude, the current magnitude as well, because the current magnitude is based off of the progress. So we do current magnitude will equal some sort of your initial magnitude times, and then we can't just do progress because if we do progress, what will happen is that it would be one. It would be one. You could either do 1 minus progress or just progress. Either one would work. I'll do 1 minus progress because 1 minus progress means you're getting your time remaining. So say you have, say you've done 75% of the time, it will become lowered. But say you want a more incremental effect and then an abrupt stop, then you could do just progress. And now we get our offset. So now we establish our offset x and our offset y. And now we just do a simple math.random. And then we times it by current magnitude. Same thing for offset. There's an issue with this. So math.random, it generates from 0 to 1, and we want to generate from so in this case, if we just did this, it would only be able to go positive. So what we would have to do is we have to just subtract by 0.5. And now, since we're subtracting by 0.5, it would be negative 0.5 to 0.5, which isn't one-to-one. So magnitude isn't a direct representation, but it is good enough. The other way you could do is you could times the random by 2. So you could then times it by 2. or you could just increase your magnitude. Either way works, but having it from the core idea is we have to have it from negative to positive of the same stuff. And now we do the elapsed time. So this dot elapsed time, and then we plus equals time dot delta time, just to show that the time is increased. And now we do an if statement, and we say, hey, if the elapsed time is greater than our max duration, there's a couple of things we want to do. We just want to turn shaking off. And we want to reset the elapsed time to 0. So now we kind of have it up here, but what we now need to do is we need to now, one final thing. Now at the very bottom, now what we do is we just call this dot. We now call this dot transform dot position dot x equals this dot base position dot x plus offset x. And we do the same thing for y. And now what this will do is if we are shaking, we generate an offset based off of the position. So if we shake a little bit, if there's no base position, then an error would occur because the camera won't follow anyone. But if there is a base position, then it will just follow whatever that position is. And then there will be an offset generated on top of that position if the camera is shaking. Yep, so now we just need to generate the start shake. Obviously, if we start shake, we want the is shaking to be true. And then the max duration would also equal duration. And then the magnitude equals the magnitude. And then one thing that we also want is the initial magnitude to equal magnitude. And then just to make sure everything is good, we just reset elapsed time to 0, just to make sure that it's not necessary, but it is just something that precaution that can help. So now say we want to go to our weekly game, and in prefabs, we go to our, not prefabs, player controller. So if we now go to our player controller, there's a couple things a couple ways we can do this. But the way I would do it now is that inside of player controller, just so that we have control of when it's happening, it's just not happening all the time. What we do is now we call camera.main.get component. We get the camera shake, and then we start shake. And now we are giving it a 0.5, and let's give it a magnitude of 20. So now, one thing to note is that I did change the scene up just to make it look, but when we jump, there is no camera shake. And that is because we didn't set the base position. So if we go back to our player controller, we set the main position to equal that. But what we need to do is we need to set the we need to do camera dot main dot get component camera shake dot base position equals this dot transform equals this dot transform dot position dot clone. And now that base position is instantiated, the camera will follow that position, and hopefully then that issue. Camera time that's camera shake is positioned. Goes this stop transform that position will clone. And when we go to camera shake, what I will do is we will console.log that's console.log offset one is the offset is what's the offset is 0, 0. Oh, it's because it's .x and .x. Copy and paste issue. Okay, and now when we jump, we kind of see that shaking happening. And it's every time we jump. So now we know that camera shake is working. We can get rid of the count.logs now. The main issue is that I see many students have, me included, was that when you kind of do this, you need to when some students implement this, that the main issue that comes across is that you need to keep track of the player that you're kind of following while also having the offset on top of that. A lot of the times, including my initial attempt at this, what happened was is that when the camera shake happened, it followed the player, but outside of that, it didn't because it only kind of kept track of the player while the camera was shaking. So that is one kind of issue that I have seen. But now we kind of have the shake. Not too disruptive, so that's good for right now. But obviously, when you jump, you don't really want to. You don't really want that because the main purpose of camera shake is to show impact. So that is why this week I will also be implementing a slashing attack and a more special kind of downwards attack. So if we go into here again and let us go to slashing attack controller and then so I spent a pretty good amount of time doing an asset called the slashing attack asset. So if we go to that, I'll briefly show it to you and you can kind of take it from there. It's like a stereotypical like parenthesis like slash attack that will be shown. If you want it, those are the coordinates that I used. But so way to implement this is inside of our player controller. What we do is so first we need to set up some way of the keys for spawning the slashing attacks. So we can do that right here. What we want is we need to establish some variables, which I've already have established for simplicity and as a reminder, but we have a next shot timer, a time, and then our current time. So what we want to do is we just want to say, hey, if our current time is greater than our next shot time, that means you can shoot. And now there's a couple ways to do this. One kind of underrated, I would say, property that's come to languages is the switch method. And one way we can do this is we can say, hey, no matter what, do the switch. And then what we can do is inside the switch, we have the case. And all we do is we just do input.keys down this frame dot includes key W. And now we can do copy and paste this to there. And now I want W, A, and D. So I don't want to shoot downwards because that kind of can be confusing. And we will reserve the downwards key for something different. But one thing that is required in all these is we have to have a break. And what we want to do on top of it, the break, is there's a couple things we kind of want to do. We first want to set this dot current time to equal 0. But then the other thing we want to do is we want to just now call instantiate. Instantiate. And we just want to do a new slashing attack game object. And when we look at the slashing attack game object, what we see is there's a duration, a scale, and a damage variable. And that will be stuff included for later. But for right now, for direction, obviously if we're pressing W, that means that the slashing attack is going upwards, which means that we need to do a 0, -1 direction. And then that needs to be in a new vector 2. And then after that, we need to instantiate a position. This can be kind of tricky because it kind of depends on your scale of where stuff is happening. But what I would do for this is I would do a new vector 2, and I would just have it inside of your X position. So wherever your X position is, it's just right there. And then I would also have it so that it's not directly in your Y position, but it's offset by your scale. So now what it'll do is it'll take your player controller and scale it based off of the scale, which would be kind of double the distance, because when we scale from the bottom to top. So we're not scaling from the center outwards. So scaling would kind of give you a good enough chunk space to actually have it spawn where it's not in collision with the player. And now we also now have to do that for your A and D. Obviously A is going to -1 direction. So it would be -1, 0. And then it will go in the positive direction for D. And in this case, we just do the Y position. We can do that for Y. It's a little bit different for Y, but that should work. And then we just want to minus this dot transform dot position or scale dot X. And in this case, since that's A, it's going left, so we minus. And then for D, we just want to add it because it's going right. One issue we will see is, well, yeah, let's demonstrate it. So we go here, and here's nope. Let's just reload to make sure nothing is spawning. Let's see. And that's because there's all of this. So let us do the slashing attack component or controller. And that makes sense why it is. But we have a direction. We just assume 0, 0, a speed, and a damage. What we want to do is we want to say, hey, if this dot direction dot x equals -1, or let's do one first. What we do is we want to rotate it. We don't want to create a whole another asset, so we just rotate it by math.pi divided by 2. So that will rotate it for 45 degrees, so that it is pointing towards the positive direction. It just so this kind of depends on how you create the asset. Obviously, if you create in one direction, if you create it in one direction, then the rotations will be different. But this is what I found to work. If this dot direction dot y equals -1, we just now do this dot transform dot rotation equals math.pi. So we rotated 180. An update, it is a simple this dot transform dot position dot x plus equals this dot direction dot x times this dot speed. Direction times speed, velocity. Same thing with y. We do direction dot y and multiply it by speed. I need console log slash note tech. Oh, outside is true. Actually, it has to be inside. We will just spawn a. Let's reload just to make sure that it is fully updated. Why is that not working? Let's try this and see if you can spawn. Oh, it is because I am not updating current time. Inside of the top, this dot current time plus equals time dot delta. And that's the issue. And now if now we can spawn it. One thing you can see is that if we were doing collisions with walls, they might collide with that bottom platform. So there might be some adjustments we have to make. For example, when spawning in the Y transform for your A and D, what I would do is I'll just minus this dot transform. Pretty much do this. Divided by 2, just to boost it up just slightly. So that now when we do it, it kind of is more up on the ground. Another thing we see is that it's just pushing them. So what we need to do now is we need to update the logic. So for on collision enter, it is as simple as saying, hey, if other dot name is basic enemy game object, we just do other dot get component, and we get their health pool controller, and we call the apply damage this dot damage. I'll go through that with you because that was kind of a while when we did this, but the health pool controller has a custom method called apply damage. There's some invulnerability stuff in there that we will have to fix, but what we do now is we just apply damage, and we say, hey, if it is not invulnerable, then we just subtract the HP, and then the health bar controller gets the component of the health pool controller of some entity and then updates it. So now when we look at it, what should happen is that it should take some damage now. The next thing we have to do is it needs to collide. So if it collides with something, usually we want it to be destroyed. So we will destroy the game object when it collides with something, and we will see that there's sometimes an issue with that. But now, there's that. One thing to note that you may see is that it got hit 4 times, but it didn't really seem like it took that much damage. The main issue is how we implemented our health pool. But another thing you may see is that, say we shoot up, we can collide with our own thing. And since it's not an enemy, it won't apply damage, but that's something we don't want to happen. So what we would do is we would just surround this with the other.name, and it does not equal player game object. And basically what this will do is, hey, if it doesn't equal the player game object, then we kind of just ignore it. So now when we do this, we can kind of not destroy it. The next thing we need to do is we need to fix the invulnerability now, because what's happening is that when you hit it, only you should have invulnerable, but right now the health pool and health bar controller, everything is invulnerable. So the very simple change is that inside of our scene, I would highly recommend you try and organize your scenes, but what I have is that the health bar game object will have a new variable. So if we go to sorry, not the health bar game object. It would be, this. It would be the health pool controller. This is on entities, and what we have now is we have has and vulnerability. So one thing we want to do now is inside of the basic enemy component, we want to make sure, or sorry, not has. So we have this has and vulnerability variable that I created prior. With this, what we want to do is we want to make sure that our player has the invulnerability. So if we go to our player game object, go to our health pool controller, and has a vulnerability to be true. Now we need to update our health pool controller. The only thing that we would have to have is that the only thing we would have to change is to say we would need an if statement in here, and we would have something like if you this dot has a vulnerability, and you set equal true. The other way to do it is set this dot is invulnerable to this dot has invulnerability. I think that would work. So if you do this dot is invulnerable equals this dot has vulnerability, I think that also works. So now if we kind of spam this, yep, they all take damage, but now I also have some invulnerability. And one way just to show that that invulnerability is still used is if we switch this to false, and then we kind of collide with the enemy or the basic enemy, we just instantly get destroyed because it changes per update. So we know that this also works. So we don't have to use another instant. So now we go over here, we have some invulnerability, and now we can kind of just spam with that stuff. So the next thing I want to do is I want to make a special attack. I want it so that when we're in the air and we click S, we apply downwards velocity, and that spawns in the two slashing game objects. One thing that's happening is that this is getting a lot, but I will implement it in here, and then maybe next time it will be refactored, and I kind of will explain the thought process, but it could just be simplest right now to kind of implement it in here. The variables I have is special attack timer, and this spawn special attack flag, basically. And what we do is I just make kind of a similar logic, but if this dot spawns, or sorry, special attack timer is greater than this dot special attack cooldown. What we want to do is now this is the other way we could have done it above, is we could have done input inside of if statement. What we do with keys down S, what we do is this dot spawn special attack equal to true. And this dot rigid body velocity dot y equals 250. So what we do now is we say, hey, if this dot special attack timer, if you can't spawn the special attack, and the keys, its keys down this frame includes the S key, we want to spawn the other part of this is, in order to do this, we want to have to be in the air in order to actually do it. So the next kind of state, we can kind of just do this right now. The next thing we have to kind of look for now is, how do we determine if we're in the air? In commercial game engines, as stated previously, there is a more expansive collision where you say on collision enter, on collision exit, and on collision stay. Obviously, if you enter a collision, you're more than likely not in the air, especially if it's not with the platform. When you exit a collision, that's like the platform, you're in the air now. So that's the simplest way to do this. But what we have to do is we have to do workaround. The kind of neat thing, the useful thing about this is our main way of changing velocity or changing our Y position or symbolizing we're in the air is when we change the velocity of the Y. We don't normally just straight up update the position of an object. We always apply a velocity to it. So the way we could do this now is we could say, hey, is the rigid body dot velocity dot Y if it does not equal 0. Now this has kind of come into a conundrum now where we also have another instance where we're hanging on the wall where our velocity is 0, but we are still in collision with the platform. And there might be some wall sliding and that stuff that you may have. So the other thing I would do is just say, and you're not inside collision with wall. And now you just say, get this in air variable equal to true, which is right here. The next thing we would do is, now that we have an air variable, we could either implement the in air logic inside of here. So if, hey, you're a special attack timer and you're in the air, then we spawn special attack. The other way to do it is inside of our collision. Obviously, what I'm intending is that we fly down, and when we hit the floor, then it kind of spawns that special attack. So I've convinced myself that we should probably have the in air in there as well. So if you're in the air, you can spawn your special attack and you spawn it. We set the special attack spawn to true, and we set a rigid body.velocity.y. The other option would be to do it later, but now what we can do now is we can set, hey, you're not in the air anymore. So we set that equal to false. And then we can just do a simple this dot spawn special attack. So now if you spawn the special attack, now you can spawn it. Now we can instantiate our A and B stuff. And this would be exactly the same, with there's some differences in which I will show you. But now we just instantiate these two. But what I want is, since this is a special attack, I want it to change. So that's why inside of the slashing attack game object, I have the scale and the damage as well. So I want to change this. So now the scale is a new vector 2, 15 by 15. And let's just do a damage of 10. This will change because I want to kind of show how you could do it based off of height. So some games where it's like, hey, the higher you slam down, the more damage you do, that type of thing. So I will also show you how to do that as well. But so now when we spawn the special attack, now what we want to do now is we just want to set the special attack timer equal to 0. We also want to set the spawn special attack equal to false. And then the final thing, this is why I did camera shake this video, is that now we can do the camera shake to show that it is an actual impact of something. So now we can actually camera shake when we do this. And then hopefully, the other thing is that with wall collisions, we just want to make sure that we set in air to false when we cloud with the wall game object as well. So now, hopefully, we do this, reload. Now, if I jump, I jump up, click S, we slam, and that does not work. We reload. So you see them spawning, but they spawn kind of weird. And that is because, again, the main issue we have is that it is spawning in a place where it automatically gets destroyed because we're in collision with the platform. So what I would do is I would just remove this divided by 2, just to make sure that there is an ample amount of room. So now if we jump up, yep, and now it works. And now it does 10 damage as well. So let's make sure. We have to wait kind of 10 seconds in between. But yep, so now that looks like it works. And you can't slam into the ground until you do it. So now if I try again, I can't do it. Now I have a. So now, now that kind of is how we spawn that special attack. But say we want it so that it happens when yeah, let's say now we want to implement the damage based on the height. Um, what we would do then is there's kind of a couple big picture things now that we have to do. One thing that is very important is in air max height, which is set to infinity, which is just a number where it's just it's something that's provided in JavaScript where it's just some very large number, positive number that we can kind of compare to for kind of the difference in max height. Um, but so what we need to do now is we need to adjust it now. So now we have to have something where it's like, hey, if we're in the air, and what we need to do is we need to check if the current transform in the y, or the position in the y, is less than the in air max height. And since it's affinity, it will always be smaller once we do that. And what we do now is we just reset the in air max height equal to this dot transform dot position dot y. What this will do is it's just simply updating it to always get the newest value that is the smallest, which in this case would be the higher you jump. And then the next thing is just calculating the damage. So when we get in, once we get into the collision, now what we need to do is we need to see the fallen height equal to this dot transform dot position dot y minus this dot in air max height. This will give us our current a positive value because when we fall, we're applying a positive velocity, which makes our position have more positive value. And we subtract it with the smaller in air height value to see kind of the distance. Now what we do is we just do a base damage just to make sure that we at least do 5 damage. And then we set damage. And what I do is I do math.max and then a math.ceiling to make sure that we do whole numbers just because that is easier. Let's just do base damage times that by some sort of the height fallen or fallen height and divide that by 50. And then the number we compare that to is we compare that to base damage. So at minimum, we will do base damage and then with the infinite max. And then the thing we now change is let's do console.log damage just to see what the damage is looking like. And then we do the damage instead of 10. One important thing that I initially forgot is we also need to reset the max height. And we need to reset it equal to what we do. So now if we open it, our damage is 5. And constant log damage. We can vary the spawn slash and attack constant log. Yep, so now you see that was 34 damage. And now if we go up here, and we jump really high and we slam down, that's 69 damage. So then you can kind of scale and adjust those numbers. So you can make it more exponential by using like an exponential an exponent to scale it. That is kind of the gist of today. Again, one thing that one issue you may have happen is that when switching scenes, there may be a error when switching scenes. That will be discussed at a later video, and probably on class on either Monday or Wednesday. Otherwise, I hope this was cool. Hope this helped with some stuff. Um, Now you kind of have a more interactive game where when you slam, it shakes the camera. You can just have that dynamic stuff. We also now include the basic attack. Um, yeah. If you need my help or assistance, you could always talk to me after class, or my email is on this list.